So let's look at a couple more example problems where we have angle addition and we're going to set up equations to find some type of missing angle. So with this problem, we're given that line PQ is perpendicular to line PS. So remember when you see this symbol here, this cross of lines where they are at 90-degree angles to each other, that just means that they are perpendicular. And knowing that they're perpendicular just tells us that they're at a right angle to each other. So this is PQ and this is PS. They are at a right angle. And we're told the measures of QPR and RPS. And we need to find QPR. So actually, let me do that in a different color. We'll do that in blue. So QPR, this is the angle we want to find. And that angle, QPR, can be written with this expression, 7x minus 9 degrees. So let's first plug that in. So 7x minus 9 degrees. We'll just set up our diagram. And we'll also put in the measure for RPS, this angle here. And this is 4x plus 22 degrees. So writing all these in, we can notice that if we combine the blue and the green angle, that they form this angle QPS, and we know this angle is 90 degrees. So these two angles, we call these complementary angles. They add up to 90 degrees. And with that information, we can set up an equation. So we have that 7x minus 9 degrees, this blue angle here, plus the green angle, this 4x plus 22 degrees. These are going to add up to 90 degrees. They're complementary angles. And from here, we just need to solve this equation. So let's combine like terms first. We'll combine the variable terms and the number terms. And 4x and 7x, that is 11x's. And minus 9 plus 22, or 22 minus 9, is 13 degrees. And this is equal to 90 degrees. So now we have a two-step equation that we want to solve. So let's cancel out the addition first. So we will subtract to do that, subtracting 13 degrees on each side. We get 11x is 90 minus 13, which is 77 degrees. And we just need to cancel out this multiplication. We will divide each side by 11. Since 11 divided by 11, that's just 1. So we get x equals 77 degrees divided by 11, which is 7 degrees. And from here, we can just plug this in. So for this angle here, we have for x is equal to 7 degrees. We have 7 times 7 degrees minus 9 degrees. So that's 49 degrees minus 9 degrees. And it looks like this angle is going to be 40 degrees. So this is what we think is the answer, but we need to double check this. And we do that by also plugging x into the other angle and then making sure these do add up to 90. So this should be 50 if we plug it in. So let's do that. We have 4 times 7 degrees plus 22 degrees. And evaluating this, we get 4 times 7, that's 28 degrees, plus 22 degrees, and that does add up to 50. So this green angle, we now know, is a 50-degree angle, and when we add 40 plus 50, we do get 90, which makes perfect sense since we already know that these lines are perpendicular or they're at a right angle to each other. So we can feel confident that the measure of QPR, this blue angle, is 40 degrees. And let's do one more of these problems. So for this problem, we're given a straight line that has this line intersecting it. So we're told the measure of QPS is a straight angle. So QPS, this angle here, is a straight angle, or basically they mean it's the angle of a line. So it's a 180-degree angle. And we're also told the measure of QPR, so QPR, this angle right here, this has the measure of 7x minus 4 degrees. And we're also told that the measure of RPS, this angle right here, this green one, this is 9x minus 40 degrees. So these two angles combined, notice, make the angle of a line. Or essentially, QPR and RPS, these two angles, these are supplementary. So they're going to add up to 180 degrees. And we can use that fact to set up an equation. So this blue one plus this green one is equal to 180. So you have that 7x minus 4 degrees plus the green one, the 9x minus 40 degrees. This is all equal to 180, since again they are supplementary angles. And from here we just need to combine like terms and solve the equation. So we'll combine the variable terms and we'll combine the number terms. 7x plus 9x, that is 16x's. Minus 4 minus 40, that's minus 44 degrees. And again, this is just equal to 180. And from here, we want to solve this two-step equation. We'll cancel out addition and subtraction first, since that's simpler. So we will add to cancel that subtraction. And we're adding 44 degrees on each side, so we get 16x is 180 plus 44, so that is 224 degrees. And lastly, we just need to cancel out this multiplication by 16. So we'll do that by dividing each side by 16. And 16 divided by 16, that's just 1, so we get x. And 16 goes into 224. Well, it goes into 22 once, and there would be 6 left over. And then 16 goes into 64 4 times. So it looks like 16 goes into 224 14 times. So x would be 14 degrees. And from this information, we can figure out what this measure of QPR is equal to. So QPR, that's our blue one. So we're going to plug that in. That x is 14 degrees. So we have 7 times 14 degrees minus 4 degrees. Let's see, 7 times 10 is 70. 7 times 4 is 28. And 70 plus 28 is 98 degrees. Taking away 4 from that, and we get 94 degrees. Now, this is what we think is our answer, but of course we should check this just to make sure that we're doing everything correctly. And to check this, we're going to plug in x to our green angle. Since we know the blue one and the green one, these should add up to 180. So if we did this correctly, this should be 86 degrees. But let's actually check that. So we have 9 multiplied by 14 degrees, and we'll subtract 40 from that. So 9 times 10 is 90. 9 times 4 is 36. Add those together, and you get 126. And taking away 40 from that, we do get back 86. And you can see 94 plus 86, that does add up to 180. So we can feel confident that the measure of angle QPR is 94 degrees.